Hello Math 1093, this is Dr. P with a video about exam question Q12, the one where you had two trigonometric equations and had to solve both of them. How awful of me, make you solve two of these. But actually the two equations both involve very different ideas, and I thought that it'd be good to assess whether you could solve each one of these, and I think in this video it'd be great if we actually went through the process of solving each of these to talk about the ideas present in each problem. Okay, so let's talk about them. Let's start with part A. So in A, we're given the equation 2 cosine of 4 theta, there we go, minus square root of 2 equals 0. Now I don't want to spend too much time dwelling on incorrect things that were done, but I think there are a few of these that we should probably talk about. First of all, there is a tendency sometimes to rewrite an equation like this as 2 times 4 cosine of theta. And we actually can't do this. This is not the same thing. In fact, one of the major themes here is that we have to think of this as being kind of a rigid, structured object. In other words, we have this theta here, and we're doing some things to it. We're multiplying it by 4, we're taking the cosine of that, then we're multiplying that by 2, and then subtracting the square root of 2 and getting 0. So there's like 5 operations being done here. We have to think of the operations as being done in that order. It's essential that they're being done in that order, and we can't really think of them in any other order, which means we're going to have to unravel them pretty much in that order, actually. So what were the 5 operations again? Now, this is something that doesn't have to be written down, but I think it's kind of a useful thing to think about. All right, so the 5 things being done are, what were they again? So take theta, multiply by 4, take the cosine, and then multiply the result by 2, and then subtract square root of 2. So I'll be successful if I can unravel those operations in the reverse order. In other words, if this is the last thing that this was done, then it's the first thing that I need to undo. Okay, so anyway, back to the equation. So how do I unravel all these things? Well, if I want to unravel subtracting square root of 2, then I need to add square root of 2 to each side. Okay, most of you did that, and that was just fine. So add square root of 2 to each side, I get 2 cosine of 4 theta equals square root of 2. All right, and then how do I undo multiplication by 2? Well, I divide by 2. Cosine of 4 theta, there we go, equals square root of 2 over 2. Okay, now this is where things get a little bit trickier, because I see this, and I want to unravel taking the cosine function, and it seems like one way to do that would be to take the inverse cosine function. And, well, I could do that, but then I'm only going to get one solution to this equation, and I would like to have as many as possible. I'd like to have all of them if I could get them. So instead of doing this, I'm going to do something a little bit different. So instead of doing this, let's think geometrically about this. Okay, and I'm going to do that up here. So let's think geometrically. I know the cosine of 4 theta is equal to square root of 2 over 2. That's a very familiar value to me, root 2 over 2. That is definitely the cosine of something. So let's figure out what that thing is. All right, in terms of the unit circle, so let's draw a unit circle here. I still haven't learned my lesson, which is draw the circle first and then draw the axes. Then you don't have to commit to where the center is. See what I did there? Like I'm way off center. Anyway, well, I guess I'll never learn. Okay, anyways, so what angles can I take the cosine of and get square root of 2 over 2? In other words, I'm going to try and figure out what this is by asking myself the question, what can I take the cosine of to get root 2 over 2? And you had a unit circle handout that would tell you that that happens when my angle is pi over 4 or when it's negative pi over 4, or if you like 7 pi over 4. Okay, I probably shouldn't say those are equal, they're not the same number, but those do give the same position on the unit circle. Alright, so here's what I know, and this is where things got a little bit chaotic. I know that 4 theta has to equal one of the following things. Either it's got to be pi over 4, plus some number of full rotations, or 4 theta has to equal negative pi over 4 plus some number of full rotations. And now this is where the ordering is very important, because many of the solutions to this were sort of on the right track up until this point. And maybe you found one of these, or maybe you found both of these. But then something funny happened. So you sort of wrote down pi over 4 and said 4 theta should equal that, and then theta should equal 1/4 of that, which is pi over 16. So I'm just dividing each side by 4. And then I sort of tack on full rotations at the end. But that doesn't capture all of the solutions. What I do know is that the thing I'm taking the cosine of, this thing, 4 theta, has to be one of these values, or this one if you prefer, one of these values plus some number of full rotations. That is the thing I'm taking the cosine of, and that's 4 theta. And we're going to get a slightly different result when we take this into account. All right, so anyway, so I know that 4 theta has to equal either this or this. So if 4 theta is equal to pi over 4 plus 2 pi k, then multiplying both sides by 1/4 gives me theta equals 1/4 of pi fourths is pi over 16 plus 1/4 of 2 pi k. And that's pi over 16 plus pi over 2 times k. The other solution gives me theta equals negative pi over 16 plus 1/4 of 2 pi k. That's negative pi over 16 plus pi over 2 times k. And in both cases, k represents an integer. And I actually do want you to write that down. K can't be just anything. It has to be an integer for any of this to make sense, because it's got to be a whole number of full rotations one way or the other. Okay, so anyway, that's the full solution to this first equation here. And that's why you might have seen on your paper that having a 2 pi k here isn't enough. We need a 1/2 of pi times k. That's because the thing that we are adding full rotations to is the thing that we're taking the cosine of in order to get this. All right, and that thing is still 4 theta. Okay, I hope that clarifies why a pi over 2 times k is needed here rather than a 2 pi k. It's that we're adding full rotations at this stage when we're deciding what it is we took the cosine of. Okay, enough pedantry on that. Let's move on to the other equation. The other equation, I'm going to need to move to a different spot in order to get room for this, but what was it? It was 5 sine of 2t minus cosine of t equals 0. Let's just move up here. I almost never go above the place where I set the intro. So this is like uncharted territory. 5 sine of 2t minus cosine of t equals 0. All right, now right off the bat, there's a couple of things about this that I'm not crazy about. One of them is that I have 2 entirely different trig functions, sine and cosine. If I could fix that, I would like to. But the other thing, and this is maybe even more crucial, is that these are being taken of 2 totally different things. Like the sine is of 2t, and the cosine is of just plain t. And I'm not going to be able to get around this by saying, oh, that's just, sorry, pen. I'm not going to be able to get around this by just saying, oh, that's 10 sine of t. That is not what that is. Having a 2 multiplied inside here does something very different from multiplying a 2 outside here. But on the formula sheet that I give you, there is a formula that tells me what sine of 2t is. That's why it's useful to have some familiarity with the formulas, even if you know I'm going to give them to you, is that if you don't have any familiarity, you don't have any idea to look for that there. Like you don't expect there to be anything that would tell you what sine of 2t is. So again, just a plug for thinking about and maybe not memorizing, but at least familiarizing yourself with these double angle formulas. Okay? And then you can look them up if necessary. Anyway, so the next step is I'm going to replace sine of 2t with 2 sine of t times cosine of t, because that'll get things to where I only have this one argument, just plain t, no 2 t's involved. All right, so 5 times 2 sine of t times cosine of t minus cosine of t is 0. All right, and then I can multiply the 5 and the 2. Now I do get 10. 10 times sine t cosine of t minus cosine of t is 0. All right, now there's 2 ways of approaching this. One of them is much better than the other one. Okay, so here's like the OK method. OK, because it does not give you all the solutions. I can move the cosine t to the other side, and then I can divide both sides by cosine of t and get 10 sine of t equals 1. But if I do this, I'm not accounting for the possibility that this might be 0. If cosine of t is 0, then I have a solution to this equation here. I have a solution to this, and that solution is not accounted for by this equation here. Like that equation says nothing about what happens if cosine of t is 0. So actually this is not really okay because I'm leaving out solutions that I should have. Because I'm dividing by something that is a variable and could be 0. I don't like that at all. So here's a better approach. Much better approach. Take what I have here and notice that there is a common factor. Cosine of t, cosine of t. Factor it out. So cosine of t times 10 sine of t, and then what do I get if I factor cosine of t out of just cosine of t? That's minus 1, and that's equal to 0. All right, so now I'm in that situation where I have two factors and the product of them is equal to 0. And I use this principle that if a product of two factors is 0, then at least one of the factors must equal 0. Okay, that's because the only way I can multiply two numbers and get 0 is if one of them is equal to 0, or both of them, but I don't think both will happen at the same time in this case. Okay, so anyway, so that means that cosine of t has to equal 0, or 10 sine of t minus 1 has to equal 0. Okay, cosine of t will equal 0. If I look at a unit circle, I can tell that'll happen when t is equal to pi over 2 or 3 pi over 2 plus some number of full rotations. Again, let's note that k needs to be an integer. Alright, so that gives me two families of solutions, pi over 2, 3 pi over 2. What about this other one? In this case, I get 10 sine of t equals 1, so sine of t has to be 1/10. And if you look at your unit circle, you'll see there's no special point that I gave you where the sine is equal to 1/10. On this one, we're going to need to write the solution in some other form. So what I can do here is I can say, well, one possible solution is the arcsine of 1/10. That'll give me a solution in the first quadrant and all of its cousins, all of its rotations. All right, so that's one. But there's another one, right? There's always two places where the sine is equal to some given value. One of them is over here. This is one place where the sine is equal to 1/10. By the way, that's a dramatization there. This should be much closer to the horizontal axis. But the other solution is going to be over here somewhere in the second quadrant. So this is in quadrant 1, and then the quadrant 2 solution is going to be the supplementary angle to that. T equals pi minus sine inverse 1/10 plus 2 pi k, where again k is an integer. Alright, so I should, by the end of this, have four solutions, or four solution families rather. This one, this one, this one, and this one, and all of their rotations. Boom, 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 boom. And this one I really do have plus 2 pi k, because the thing that I'm taking the cosine or sine of is just plain t. Okay, so none of this pi over 2 times k business or anything. Anyway, there's a lot that goes into that, but the thing that you had to do first and foremost in order to get started productively was know that sine of 2t can be rewritten, and it's rewritten using this identity here, that double angle identity. So if you see one of these where you have an equation and there's a couple of trig functions and one of them is like a double angle, probably the first thing you need to do is get that double angle in terms of something else. Alright, so that's the end of that problem, and got one more video to come.